The process of mistake proofing breaks down into 4 main steps: map the process, identify risk points, apply mistake proofing tactics, and check effectiveness. The first is to map the process. Each step in a process is a potential source of error. Identifying all the steps and decision points ensures that no key part is left out. And sometimes, after breaking down the process, the source of the mistakes is obvious. The second step is to identify risk points. This means looking at each step in terms of the probability of mistakes and the severity of those mistakes. It is not necessary to conduct a complete failure mode and effects analysis for each step in the process. The important thing is to consider the key risk points. The third step is to apply recognized mistake-proofing tactics to the steps with the most associated risk. There are many tactics, so rather than apply them in a random fashion, we suggest the following logical sequence. First, determine if you can eliminate the step. Simply put, if you eliminate the step, you can't make a mistake while performing it. Many processes can be simplified, resulting in far fewer associated steps and decision points. Second, look for ways to constrain the process so it is impossible to make a mistake. For example, many laboratories use reagent barcode systems to make sure expired reagents cannot be used. If the step can't be eliminated, and if the process can't be constrained to prevent mistakes, a third option is to make it easy to do the right thing. There are many techniques that can accomplish this. For example, improving visibility, improving documentation and job aids, building in prompts and warnings. The fourth option is to build in checks and backup to identify mistakes we were not able to prevent before they move on to cause problems. A fifth option is to create sensory alerts to make mistakes apparent or stop the process. After applying these 5 sets of tactics, the final phase in the process is to check effectiveness. We may be excited about our analysis and the mistake-proofing ideas we applied, but did they work in the real world? Was the intervention effective in preventing mistakes? We need to do the experiment, learn from the results, and possibly take a fresh look at the problem if the intervention did not accomplish what we hoped.